Recording in progress. Hello, my name is Joseph Judman. Virtual background. Okay, I don't have one. And today, I'm making this video for fun because I'm bored. Now, I did spend an hour approximately, or maybe more, trying to share my screen or share my camera. Share my camera. This is an Ubuntu laptop. Right? It has Ubuntu stuff on it. And you can see all the stuff I've been trying to do. History up to about here, here, up to about here. Those are all commands that I ran, even up to sudo chown, even up to here that I ran trying to get my camera to work, but it's not working, so we don't need it to work. I'm making this video because I'm gonna do the Advent of Code thing. I want to do it every day. The next one comes out in an hour, so we'll see how that goes. But I'm not gonna lie, I've read this already. I read it and I went to shower. We basically want to take this, put it in a list, take this, put it in a list, get the min from this and the min from this, and sum them. So nice and easy. So like for this, the min is 1 on the left, and the min on the right is like 3. So 1 minus 3, like their difference, the magnitude of their difference. 1 minus 3 is -2. Take the magnitude's 2, right? And then, so that first thing is 2 here. Okay, now we go to the second smallest number, which is 2, and the second smallest number here is still 3 because there's duplicates. The difference between 2 and 3 is 1. Okay, now we have 3 and 3. That difference is 0, and we keep going. Now, I've done zero coding with this, zero coding, but I get kind of excited for Advent of Code. It's kind of an exciting thing. So I wanted to take a crack at it. So this is completely raw. I've thought about the problem quite a bit, but I haven't really done any. I'll call it 2024 Advent of Code, or a Advent of Code 2024. Yeah, Advent of Code. Okay, I'm gonna do this in Rust because I like Rust. No, chow one, chow one, challenge 1-1. Okay, little NeoVim. We're just getting in here, trying to see what's going on. There we go. So this is a little environment. Over here you see Hello World. Okay. I change it to Hello YouTube. The output changes, right? You can do tests, you can do Clippy, you can do a check somehow, but we're just gonna leave it in run mode, see what the output is. So the first thing is that we have our puzzle input and it's quite large. I don't even want to read it right now, but we want to be able to read a file, say input txt, and that'll be this, something like that, right? So I'll move that over. This is all in a GitHub repo, so I might do like committing, but we'll see. So the first thing I want to do is reading a file. I haven't written Rust in a very long time. Is it import? Is it use? That sounds right. Use standard FS. File system manipulation operations. Okay. So the main idea is that we want the min item. So immediately, like thinking out loud, a brute force solution, you take an array of numbers and you linear search for the smallest, and then you remove it and you linear search for smallest. But at that point, don't use an array. Use like a set with, well, you can't use a set because there can be duplicates, right? So you could use a map with the numbers and their frequencies, and you take the smallest number that doesn't have a value of 0, right? Do I have some kind of like some kind of draw, like a whiteboard or something? Online free. I swear to God, if this hits me with an ad, I'm going to kill myself. Oh my God. Okay. I don't like not being able to draw. Is there like Paint on a bin on Linux? I really only use Linux for programming. GIMP. Is GIMP on here? No. Draw. Okay, guys. No drawings. But I'm thinking, right? You can do something like that. I guess we could use a priority queue or shit, let's just use a min heap. Min heap in Rust. Nice. So listen, my computer's listening to me. So you have a binary heap in standard collections. Okay. Collections, binary heap. Okay, let's read some documentation. It's my favorite thing to do. A priority queue implemented with a binary heap. This will be a max heap. You're fucking kidding me. Is there like a reverse operation? Is it a logic error for an item to be modified in a way such that the item's ordering relative to any other item determined by the ORD trait changes what's in the heap? This is normally only possible through a mutable iterator. A lot of Rust jargon that I'm familiar with. There's an example. Beautiful. Standard collections binary heap. You make a new one. You can peek at it and it gives you like a sum. You push values to it. Peek sum 5. Length heap. You can pop shit off the heap. Popping sometimes can be popping is safe because it can return none. It's like a beautiful Rust implementation, right? You could tell. Look at this. Typically, like in C, this would segfault, it just returns none. It's nice. You can clear it. You can assert that it's empty. Going to be initialized from an array. Ooh, it's moved in. I'm not going to be able to have this as an array though. I'd have it as a vector, and it's like 2. I'm going to end up building the heap not in place. Either core, comp, reverse. Ooh, min heap. Core, comp, reverse, or custom order implementation. It makes pop return the smallest, and you just wrap all your things in reverse, and you have some time complexities. Beautiful. The only thing that's it's log n to pop. Okay. So I'm looking at this and I'm thinking about making a min heap. And I'm looking at this, but I'm wondering if we don't need the min heap, right? Um, Point being, like if we do smallest, then second smallest, then third smallest, and we do that sum, biggest, then second biggest, then third biggest would be the same ordering, right? Least to greatest and greatest to least down the line is the same. So we're just going to end up using a max heap because that's what it comes with. And it's an equivalent solution. So the first part is going to be we want to read the file line by line. And we're going to have a little file name here. I believe I called it input txt. Rewrite as raw string. Nope, not what I wanted. Syntax error. You gotta stick with me here. I haven't written much Rust in a long time. Missing type for const or static. Should have uppercase snake name. Okay, so the first thing is Clippy's unhappy, which is not cool. Let's fix that. And we'll go over to bacon and maybe get a better error message. Provide a type for the constant reference to string. So the thing is, this guy's technically a static, and I guess he is just by default because he's a string literal. So he lives in the binary, but it doesn't hurt to be explicit. Um, and they're kind of const already. I don't care. It's nice to declare that as a constant. And next is going to be read the input line by line. Read this. Okay, so we gotta get something out of files fs dot fs colon colon hello. There we go. Read reader remove file. Read hello. Read to string. Read an entire contents of a file into a string. I was just hoping to iterate over a file. Return it into a bytes vector. Fuck you. I want to just read lines. Is there like a lines? No, so it won't be fast, but we'll read to string. Okay, this was really upsetting me. There we go. Read to string. And so instead of, I think it's important to note that this comes from the file system. So we'll stick the file name in here and hopefully it's just happy with that. Okay. Um, Now it's complaining that there's a result. And this is why I like writing Rust, because you just go line by line. The compiler kind of tells you what's wrong. This guy too returns an IO result. So, I mean, if we can't like read the file, we're kind of screwed. And so now we have our raw file. And it said reads a string, so I'm guessing it's a string, like that. Unused value, and we're not using the binary heap right just yet. Okay. And now I guess we're going to want to populate two different binary heaps, binary max heaps in this case, with values. Okay. And we've got, the let LHS, this is left-hand side. Hopefully you can see the left-hand side here. Equal binary. I'm really not happy with my LSP right now. Hello? Are you working? LSP info. You're not. Rust analyzer. Rust. It's true. Root directory not found. File type C rust. Past grep. Hmm. So you're working. There's someone outside. My roommate might be home. If I type something like raw file, I get I get inference. It's good enough. Anyways, we're gonna at the left-hand side equal binary heap new, and same for the right-hand side. I thought I heard someone at my door, but I guess not. Type annotations needed for binary heap can't satisfy your ORD type. I don't think they use that in the docs, did they? Would be binary heap I32 in this example. Okay, so I guess again in the interest of being explicit, that didn't work. Hmm. We'll see if those type inferences kind of come in as time goes on. LHS dot, is there an insert? Push? Yeah, what if I just push like a one into it? It stops complaining? Cool. And we need these to be mutable, of course, because we're going to be filling them up, right? We're going to be populating them. I wonder if we could do a collect. Hmm. It's worth thinking about, but we'll get to that. So essentially, we want to go through this string that we have line by line and put the left-hand side and the left-hand side and the right-hand side and the right-hand side. Right? So we'll think about that. So I guess we just want to raw file. I'm a big fan of iterators. Dot lines dot collect. No, I guess for each line. All right, there's no map where we're transforming each line. There's no filter. There's no accumulator. It really is just sort of for each, right? And we have the line. I wonder if these numbers are only ever single digit. Clearly not. They are separated by some strange character. But we have the line, which in our case is a reference to a string, and we're going to do something with that. Probably just, line dot split, maybe. Split once, and that delimiter, hopefully this is a single character. This like delimiter doesn't look like a traditional space. Weird. But anyways, yeah, there it is. Maybe it's a tab. What does split once return? It returns an option with a string and a string and their lifetime. So again, we expect the input to be of this form. I don't really care about the unhappy path. And we can let ln rn, left number, right number. Character literal may contain one code point. Maybe I should do this. Is it literally? Hmm, I don't know what this character is. Hopefully that just works, but this is I think it's worth putting a to do this might break since it's a wonky character. Right, I'm not super sure what this character is. It's not just a space. They're delimited by something a little bit weird. But now we have a left number and a right number. Um, and I guess we just want to LHS push the left number and right hand side push the right number, right? And now, but they're strings, right? So, hmm, I'm gonna take this to do out because it's in my head. They're strings and we want them to be integers, right? I want these guys to be, I32s. They should be U32s, right? But I don't care enough. We found string. So I wonder if instead of an unwrap, I can do like a map where I can like get at the interior, and then we have RS, LS, and like a little tuple, right string, left string. Yeah, and we just return like another tuple, RS dot to, can I just say into? LS into dot unwrap. The trait from is not implemented for I32, which is required by string. I'd like to not Google how to convert a string to an integer, but I might do that. The trait from stir is not implemented for I32, which is required by string. It can come from a bool, a 16. Um, hmm. How to convert a string to an integer? Is there something in I32? From stir radix. Converts a string slice in a given base to an integer. The string is expected to be an optional plus sign followed by digits. Leading and trail white space represent an error. Digits are a subset of these characters depending on your radix, and it returns a result parsing error. So this is part of the reason Rust isn't great. Um, it's a little bit ugly. I'm gonna do a kind of goofy trick where I do that to clean up some of my Vim. So now, right, we've got our line, which we split, and now we're gonna map. And I'd really rather that like line up. And so I'd really rather everything line up. Rust Analyzer does not feel like formatting this right now. So this, right? And then like, I wonder if you do that for me. That's a little better. Expected semicolon. Shut up, Rust Analyzer. You don't understand what I'm doing. So basically, we want to return a tuple, which is, the I32 from stir radix, where the source is the left-hand side, which would be on the left, dumbass. And we're in base 10, of course. And then because like this is a very verbose. I feel like someone who doesn't understand Rust, or even someone who does, would have some trouble like reading and understanding what this code represents, right? We'll go over it in a sec if you're not following, but basically you hit it with an unwrap and you're good. And we also hit these with unwraps. So it's a little fucking goofy, right? Like, and I forgot to do, there we go. So if you saw this and it upset you, then you're correct. But basically, we're getting the I-32 left and right values, this and this. So we start with this whole string. We know it's delimited by this weird medium character. So we kind of split on that. We get a left and a right number, which might be a single digit, or they could be quite large, right? And then we convert from a string to an integer with this very verbose function, which also could return an error, but we know that it won't. And now we have this, which is a pair of integers, but this whole thing could have errored from the split or something. Yeah, this whole thing could have errored from the split, so we unwrap it, and I don't know why it's not, oh my Christ, why it's not like formatted well. Rust doesn't like the way I think. Something like this probably looks nice. And so basically convert the line to two ints left and right. Crash on any error, right? So now we take those numbers and we put them in the min heaps. So this iterator here, so to go over what I've done, an iterator can get ugly like this. For each line, we get the left and right number and then add it to the thing. And so this is closure kind of implicitly captures our heaps, but I don't think that matters. Okay, so this should really go here. Here are our max heaps. And I guess a good thing to do is assert that the left-hand side size isn't really num. Are you serious? Size isn't on the standard binary heap. It's length. Man, screw you. You'd want the left-hand side length to equal the right-hand side length. Just like sanity check, you know? I just ran the formatter and it seemed a little more happy now that there aren't any errors. If we run this, you'll see that it doesn't, oh, it does have an error. OS kind not found message, no such file or directory. So it's possible that, yeah, this is should be input.txt. And now it's running, and you can see the assert isn't having an issue. So this is kind of like testing as you go. If I said that this should not be equal, right, and I ran and I go to the assert, you'll see the assert fails. And so even though I'm not running or printing anything, I can see that there's no errors because this is running in real time. So I guess now we just drain the heaps slowly and do some crazy brazy adding. All right. So I guess we're just gonna, I hate to do a loop, but we'll do a loop. Maybe a while loop. Rust doesn't have while loops, I don't think. So a loop, and I guess we'll just first we'll have when either is empty, we are done. Okay. And if length of, we'll do the left-hand side. I know they're equal, so it doesn't matter. If it's 0, we can break out of this loop. Around if condition. Remove parentheses. Sure. I don't like this, but I'm leaving it on one line. Okay, so we just kind of we've performed this check, so I mean we'll have a mute sum, which is an I-32. Why not? No need to complicate it with other types. Uh, something like that. Unused sum by default, and we're just going to print line the sum. But we can't just print line sum like this because that would be too nice. We have to print line something like something like this and then say sum. But I like a little the sum is something like that. Let's make it a proper sentence, even though it's not important. So I guess we just add the difference of the mins of the maxes to the sum. So we're gonna have our difference is an I32. Um, and it's just gonna be left-hand side dot pop dot unwrap minus right-hand side dot pop dot unwrap, and we can call unwrap here. Maybe is there a pop unsafe? No, we could have done that. We want to do this, but this whole thing we want to wrap in parentheses, and I wonder if there's like an absolute value somewhere that I can run. So for one, I'll look for that in a second. To do abs, right? For now, we just want the sum to get the difference, and that's it. Because popping actually does take something off. Anyways, I'm wondering if there's like a standard math module, standard arith. Where would they define an absolute value? I32 abs. Computes the absolute value of self. Perfect. Okay. It's going to be I32 abs. Something like that. Right? And I bet this just runs. Yeah, the sum is 11. So not a super hard challenge. It says the actual value is 11. So we'll grab our puzzle input and we'll stick it in the input. This is a lovely intro to Advent of Code. Um, this should be our puzzle answer. So we take it, we paste it, and we submit it, and that's the right answer. You're one gold star closer to finding the chief historian. Now, I like doing both parts, so we'll see. Part two. Now, I haven't read this. This is real, so I want to lock in and look cool for this. Your analysis only confirmed what everyone feared. The two lists of location IDs are indeed very different. Or are they? The historians can't agree on which group made the mistakes or how to read most of the chief's handwriting. But in the commotion, you notice an interesting detail. A lot of locations. There's a lot in both lists. Maybe the other numbers aren't location IDs at all, but rather misinterpreted handwriting. I'm not following. This time you'll need to figure out exactly how often each number from the left list appears in the right list. Calculate a total similarity score by adding up each number in the left list after multiplying it by the number of times that number appears in the right list. Here's the same example from before. For these lists, here's the process of finding the similarity score. The first number in the left list is 3 and appears in the right list 3 times, so the similarity score increases by 3. The second number in the left list is 4. It appears in the right list once, so the similarity score increases by 4 times 0. So for the first problem, we used min heaps, and we'll do a little get. This is the first part. I used min heaps and evil iterators. There we go. That's lazy git if you like that. There's a extension on Packer that lets you just have it pop up in NeoVim. It's nice. So this first part, the data structure we were using, and this really is just a data structures problem. Um, it's asking us, hey, do you know how to use a priority queue? Do you know how to use a min heap? Maybe some people for this first part used maps and they went through the biggest key to the smallest key, like an ordered map, maybe something like with a red black tree in the background. I know C++ uses a red black tree in the background, and that's quite interesting. But like an interesting approach. I don't know if it would have been like less space than mine because I needed two binary trees, right? Or binary heaps. They're trees. They're a type of tree. They're a type of complete tree. So I don't know. Like this is like very classic hash map. If you didn't read this and think hash map, you should do more leak code or something. I don't do leak code. I'm not a fan. Right? You take all of these numbers, the frequencies of these numbers, and you stick them in a map, and then you just take this number and you look it up in the map and you multiply it by the score, and then you take this number, you look it up in the map. Now, considering the fact that we're going to call n the number of rows, right? It's going to be O of n to build the map, and then it's going to be O of n, right? Because we have to go to each of these once. And for a really good hash map, it's O of 1. I don't know if Rust's hash map, it could be log n. So this could be n log n, maybe in the worst case with a really poor hashing function or an ordered map implementation in the background, or maybe they have some like linear address probing or something. But so building the hash map is O of n, or maybe at worst O of n log n if you have a crappy compiler, and then you have to go through again. Lookups are just O of 1, but you'd have to go through n times. So the final complexity of the thing I'm thinking of is n plus n log n, which is quite shit. Um, I'm trying to think if there's a way to do it in one pass before I go down this rabbit hole. Um, there can't be a way to do it in one pass because I need to know everything, right? The other way I could build two maps, right? And I could just multiply the values of the overlapping keys. No. Yeah. I could do it in one. So now I'm thinking about making two maps instead of one map. Right? If I made two maps and they're both going to be the same kind of map, the number four appears once, so this map will have 4, 1. The number three appears 3 times, so this map will also have 3, 3. It'll have 5, 1. It'll have 9, 1. Okay, we have a second map, 3, 4, 2, 1. And then when we're done at the very end, we're going to have two maps with keys and frequencies. And then any keys from the left map that exists in the right map, we just need to do key times right map value. It's an interesting approach, and I'd say it's O of n, maybe O of n log n, but it's not because we have to do this solution is n log n also because we have to build the map, which is still n log n, right? We have to build a map period, and then we have to go through each key, n keys, right? So either way, it's n log n. And so I don't think there's a reason to split hairs or to not split hairs. Um, yeah, so honestly, like this whole thing is shit for hmm. Sort of. We can keep we'll work on it. So instead of a binary heap, we're going to use a standard collections. I think it's a hash map. Hash set, hash map, hash map. Hash map? Or they just have a map. It's a hash map. You're a module and you're a struct. Quadratic probing, yeah, like a quadratic probing hash map isn't very good, especially when you don't have a lot of data. I guess our puzzle input is pretty massive. Um, so that would be fine. It's gonna run in like less than a second, but I like being and a reasonable best effort is made. A reasonable best effort. I'm not very. I know Rush's HashMap implementation isn't the greatest. Keep clicking out of the docs. Yeah, I know what a hash function is. Don't tell me that. You have a hash map, you make new, you can insert, string to string. Sure. The keys must be hashable. We have get and can be initialized from an array. Okay. So we'll use a hash map and we'll start stepping through this. We're going to need one map this time. Let right-hand side equal hash map new. And again, it's like I don't know the type, but we'll get to that, right? Rust is really good at inferring stuff once you work with it. So I really just can't stand the fucking shit yelling at me, so I'm gonna delete all of it. And we're gonna delete this, and we're gonna delete this. And this will stay because, we're in here. But here's my general idea. We still go line for line. We still go band for band. And we still need this line. But we don't need that second value when we're building the right-hand side map in place, right? We don't need this LHS value. And so, hmm, we really only want the right number, which is really just an I-32. And then we're just going to split the line on once. We're going to ignore the LS. We don't need it. We don't need this. And there we go. Rust format, beautiful. So we could reuse some of our input parsing code from the previous section, and we just kind of ignore our thing here. Now this line, this number is just going to be 4, and then it'll be 3, and then it'll be 5, and then it'll be 3, and then it'll be 9, and it'll be 3. Now I want to make sure that our new puzzle input doesn't contain negative numbers. It doesn't. And that we have the same number of left and right inputs. Just basic stuff, yeah. So basically we just take this right number and we just say that the right-hand side is going to get inserted. Inserts a key value into the map. I want to read the docs because hash map behaviors, everyone does it differently. Inserts key value pair into the map. If the map did not have this key present, none is returned. If the map did have this key present, the value is updated and the old value is returned. He's not updated though. This matters for types that can be equaled without being identical. It means nothing to me. I want like a update or insert. I know that Rust has this because I've read the book. What type of malarkey? Length, call, keys, values, hash, or get. Returns a reference to the value corresponding to the key. Is there a get mute? Yeah. And we'll get mute RN, right? And then this value, expected unknown found I-32. You know what? Fine, I'll tell you what the type is. Just stop bitching. Hash map of I-32 to I-32. And again, I know it should be U32, but we'll live. Expected a reference to I-32 found in I-32. Do you just want me to, can I mutate a mutable variable? Well, it should be immutable. Should be mutable. Okay. So get mute. Now this returns an option to a mutable reference. And so I think a great thing to do here is either a pattern matching or an if let, because if it exists, we want to increment it, and if it doesn't, we want to insert it and um, set it to 1, right? Um, it would be nice if I knew that the default value when you insert it was 0 and that I just insert and plus equal 1, but I don't know that, right? So thinking, I guess if let's fine. I don't like the idea of having a mutable reference and then trying to mutate it. I actually really don't. What am I doing? Oh, caps lock is on. I was like, what am I doing? Okay, I'll try it, and I think I'm gonna run into the borrow checker, but we'll see. If this equals some value, right? Then we can do something. Hmm. If let, remind me how if let works. Don't care, don't care. If let sum I, it's the other way. Duh, why didn't I think of that? Duh. if let some value equal. Okay, right. And in this case, I have the immutable reference or the mutable reference, and I can just say val plus plus expected expression. Why? Why are you expecting an expression? What do you mean? There's no such thing as a valid postfix operator. Cannot mutate immutable variable val. Some mutable val. Binary assignment operation cannot be applied to reference mutability to I32. What do you mean? Cannot use plus equal operation. Can be used on I30 if you dereference the left-hand side. Variable doesn't need to be mutable. So some fucking Rust shenanigans, right? But if there's a value, we increment it. That's the first part of the desired behavior. And otherwise, we want to right-hand side dot insert. The key is going to be the number, right number. Oop. And the value, oops, is going to be 1, right? Because we just saw it for the first time. See if that format's better. And so I don't really like this, but it does exactly what we want, right? So going over for each line, we get the number on the right. And then if that number already exists in the map, we increment it. And if it doesn't, go ahead and insert it. There might be a more elegant way to do this, but it's basically going to get compiled down to the same thing. From this point, we have our map. And so this is the where I said it was n log n plus n. This bit was n log n, assuming insertion is log n, which for an ordered map it would be. But it didn't say if this hash map was ordered or not. It implements iterator, I think. So order, unorder, doesn't say. So anyways, now we just go over the map and do the thing. So the reason I didn't store this guy into a map too, and then just go through the map, is if I just stored this guy into the map, the right-hand side, then I have to go through the left-hand side bit by bit, line by line, and build my sum. Whereas if I just build them both into a map, like I have to go through one of the whole maps anyways. And yeah, map lookups are O of 1, but it's going to be n times, so it's going to be O of n. And so whether I have to go through it twice or go through it once and then go through the map once, it's O of n. And the space complexity of declaring another map in my head isn't really worth. And it's also like not that deep. I'd love it if lines like didn't consume string. Yeah, it takes a reference to self. So what we can do, which is just awesome, is we can take this code and I love not writing dry code. So we're just going to do this and we're going to have the left number and we're going to left side underscore left side the value. And then we're not going to do this, of course. And there we go. So now I've taken this code and we're getting the left number in this little block, 3, then 4, then 2, then 1, then 3, then 3. Then we're going to have a mutable sum, right? And we're just going to say that the sum is, you know, it's the right-hand side get by this key, and we'll just say it's unwrapper 0 times the key itself. Expected a reference to an I32 found in I32 where? Consider borrowing here. Like this? No? This is something like, why can't you just borrow it for me? Is it both of them? It is. Like, this is stupid. These are numbers. You know what I mean? Do that for me. I don't know. Anyways. It's because these are nice clone types. This is super easy. But I guess it would be more of a pain in my ass if they were complicated. Do a little format, please. So I have the sum and RHS get is basically like we pull up 4 and we see that 4 only appears once. So this number is 1, right? If it doesn't appear, they said to use 0, right? So that's what this unwrap OR is. And of course, it's a reference to 0, which is just great. Um, and then they said to multiply it by the number we were looking up. So 2, we looked up, we got 0. 4, we looked up, we found 1. 3, we looked up, we'll find 3. And so that's this. And now I think one of my roommates is home. It's kind of scaring me when I hear like the something go bump in the night, you know. So in fact, I'm gonna lock my door. I'm a little scared. I'm a little scaredy cat. Nobody can know that I'm cooking on Advent of Code. And let's just say um the sum is. And again, keep it professional. And it says that this is our sum, but I'd prefer if we used the example input on our input txt like that. And they say that the answer, example answer is 31. So I pull up and it hasn't rerun 31. Okay, so it looks like it's working on a small scale. So I think it's new puzzle input, but it doesn't really matter because I'm just gonna paste it again, run it. We have our new, I killed bacon. Great job, Joseph. Uh, real fucking smart of you. There we go. And we submit it and it's loading. We might have gotten it wrong. Nope. Awesome. That's the right answer. You're one gold star closer to finding the chief historian. Awesome. Very cool. So quit out of bacon. We quit out of here. We go into main. My solution is 43 lines long, and if I got rid of the white space, it would be 37 lines long, but I'm not doing that. And I guess we can do a little commit and say second part, done and dusted. I'm a little bit disappointed that I didn't run into some kind of issue. This was pretty de facto, pretty by the book, pretty, hey, what data structure do you think you should use when it's a heap problem? Hey, what data structure do you think you should use when it's a map problem? Should you make 2 maps or 1 map? Oh, it's the same. I would have liked for a pitfall or something. It's an excellent little intro, but I like a little bit more of a challenge, maybe, hopefully. This was definitely fun. I'll be doing the next problem whenever it comes out. 30 minutes. I'm not doing that. I'm going to bed. But 2 stars, I'm pretty proud of getting them both first try. That's pretty cool. Rust is a pretty robust language for stuff like this. I don't know if I'll make videos for the rest of them, especially because I've